Good evening. Thank you for coming. I am Carl Sagan. I'm here to tell you about future space missions and current ones going on right now with SpaceX, NASA, and the ESA, European Space Agency, as well as other countries like China and Russia. But first, I always like to talk about myself. So briefly, I'll talk that I was born in 1934 in New Jersey and had an interest in science fiction and astronomy at an early age. I got my bachelor's, master's, and PhD at the University of Chicago in planetary science and astrophysics. And I was first to recognize that amino acids could be discovered and worked on with basic building blocks that are basic building blocks from basic chemicals through radiation. I worked on the Mariner project out to Venus, and I worked on the Viking project out to Mars. And working out of Cornell, I wrote 17 books describing astronomy. One of them was a Pulitzer, another turned into a TV show called Cosmos, and another a movie. And I inspired millions of people to be interested in astronomy. And I'm quite an inspiration. So now we're going to talk about some countries right now, like China. We're right now in a space race with China. It has an ambitious and robust space program. They launched Zhuring about in 2019, landed on Mars and stayed on there for a rover for a year. They landed another rover on the south pole of the moon in 2020, and then just this summer they were with Chang'e. They were on the moon's south pole, and they brought back 4.5 pounds of rocks from the south pole. Okay, what's so special about the South Pole? That is the current interest right now, what's going on. Well, they have the Aitken Basin down there that's 1,600 miles in diameter and has these craters on it that could be 4 miles deep. And also, moon South Pole, they want to put a moon base there because it has a lot of untapped resources like these kind of hydrogen, ammonia, methane in the regolith, which is the dust the astronauts were walking through. Plus it has 100 million tons of water deep in those craters because the sun does not get inside those craters. It's at a low angle and it's shaded. It's really about 130 degrees on the moon's south pole, and it hasn't melted away. So it also has, this means it has 650 square miles of water. That water is here. And what's really important about water on the moon or water anywhere we go outside of Earth is that, first of all, if you find this water, mine it, thaw it out, filter it, obviously to drink it, but you could put an electrode in the thawed out water and through electrolysis separate the hydrogen and oxygen to be able to make air to breathe. That's why water is also important, and also it's expensive. Why this gallon of water takes $25,000 to put on the space station or in the LEO, low Earth orbit. It takes $100,000 to put this gallon, which weighs 9 pounds, on the ISS, on the moon, and it takes $1 million to put this on Mars. $25,000, $100,000, $1 million. That's why it's expensive. So that's why they want to find water on the moon. And a lot of countries are interested in the South Pole. The Chinese have a space station called Tiangong. It's been up there for 2 years. It's 3,900 cubic feet. The ISS is 13,600 cubic feet. And 3 astronauts have been up there, and they trade off astronauts. It looks like this in 3 sections. This is what it looks like. And they're orbiting at the same height as the ISS, about 250 miles up, and about the same speed, about 17,000 mph. And this is what it looked like. Here are some crew members from there. And they test their own bodies up there like we do, and they have fluid experiments and biotech experiments up there. This is how they get up there in a small capsule. This is what it looks like inside Tiangong. And they want to put more modules on it to be able to attach and work on and fix the Dunching telescope that will go up next year. And they want to use it to their space station to repair this in case it breaks. It'll be a 6.5-foot mirror, and will have 300 times the view that the Hubble has. And they have plans to put a moon base on the moon. And one of their plans is to have that regolith and put it in a 3D printer, heat it up to 1800 degrees on the moon's surface using solar panels as to get energy from, and make bricks to do this. That's what they think. I'm not sure if that's going to work. But these plans are all actually just, they want to show this to you without the regolith on top of this, because you need that on top of the moon's basically soil to prevent you from having too much radiation. But we're not sure if they can do this kind of thing right now. But these are just preliminary ideas. With most of these plans, illustrators make more money on this than anybody else. So this is how they go up. They have 4 space launch areas, 2 in the north and 2 in the south. And they land on grass. And this is just propaganda of what this might look like way, way in the future. Nothing like this will be built during our lifetime. This would bankrupt the Chinese economy. However, this is what they're thinking of doing this. They spend about 12 billion a year on space. We spend about 25 billion. And they have this idea called the International Lunar Research Station to be on the South Pole. They've attracted 10 countries to be with them. And again, this is what it might look like, but it'll be nuclear powered, if that. I can't imagine, if it's nuclear powered, that means they have to take up 10 pounds of plutonium in their spaceship. I'm not sure if I want to be an astronaut doing that.
Carl.
So, they want to look like this, but this will have to be covered with soil again. But this is their idea. They're in combination with other countries doing this.
Carl, when do we ask questions? Later?
Later. Thank you. Didn't know. Thank you. So that's the International Research Station. Russia had a lander that tried to get on the moon but crashed, Moon 25, about a few years back. And here they are getting to the ISS, because they have a Russian segment to it, which is right here, and we have an American segment to it. They want to make, they want to make a new space station because the old one is being worn out. They've had it for over close to 25 years up there. And they want to build a new space station called the ROS, the Russian Orbital Service Station, and they want to put it in a higher orbit, like 300, 350 miles up. And what they want to do is use it to look at the Arctic Ocean, because this ice will melt, and the ice is 5 to 10 feet thick. One day it will melt because of what we're doing to our planet, and that way they can plan and be able to triangulate ships to go through this for shipping, and they look for oil and gas, which is tens of thousands of square miles of ocean that they can go look into from way above. So that's their idea for the Russians. And they do very good at doing that. Another country like India has been getting involved in the space race. They put up a probe called Mangalan that went around, that orbited Mars, and it looked like this. It did that for 8 years. Currently, India has the Vikram lander on the south pole of the moon. They're interested in the south pole also. It has the Vikram lander on the south pole, and it has a rover called Pragyan right here. And the rover comes out of it down the ramp, and it's solar powered with 6 wheels and explore the moon. And right now it's in sleep mode. And they work in combination with JAXA, which is the Japanese space industry. And this is the next one we'll be talking about. So Japan also has a robust program and likes to work directly with other countries. And they right now they brought back a rock from the asteroid Ryugu, and they went out there. The asteroid is between Mars and Jupiter in the asteroid belt, and we'll be able to retrieve a little bit of sample to study it. Asteroids are important because they're primordial sources of when the solar system developed 4.5 years ago. Thank you for turning that. And they also have going out to asteroid 1998 KY26, which is a small asteroid. It's a 10-year mission to go out there to study this. And they also have on the ISS called Kibo a place where there's 23 outside racks where they can do experiments in space. This astronaut is retrieving those experiments in situ. So Japan is a very willing partner to work with other people. Also, other countries like to put up satellites, like Brazil, for weather, communication, and defense. And this really helps out the country. Actually, there's about 3,100 satellite, I'm wrong, over 30,000 satellites in orbit around the Earth, but only about 3,000, about 10%, are actually functional. Also, like South Korea, also wants to get involved in this and has satellites too. Its counterpart, North Korea, launched this, and if you notice, North Korea is completely dark at night and only lit up in the areas where they have a lot of money, its capital city, Pyongyang. So this is what it looks like night and day, literally. Now we'll talk about ESA, European Space Agency, that has ongoing ones and future ones. We will talk about the ongoing ones first, and then the future ones. They have 15 countries, and they each contribute about $500 million to their budget of $8 billion. And they're wonderful people to work with because there are so many countries that like to get involved in this, and they have so many great ideas. One of them is the ESA's Euclid, which is the Space Telescope, which launched in July of 23. It is in the L2 orbit, which is 900,000 miles away from Earth, about 1 million miles out. And what it does out there is it's away from Earth's shadow, and it's able to conserve energy doing this. It's a space telescope out there, and has a solar panel. And I wanted to make sure that you know about this, that it's protected by these panels in back of it to protect it from being overheated. I'll bring this up a couple of times. And it's studying it's making a 3D map of the universe out to about 10 billion light years. And it wants to study and explore the areas of dark matter and dark energy, which we know very little of. Dark matter is the cosmic glue that holds things together, and dark energy is the stuff that makes space expand. This constitutes 90% of our universe, but we don't know much about it at all. We only see about 5% with our telescopes. That is basically white light. Let's explain that, and this will greatly enhance what we're doing. It has a 4-foot diameter mirror on it and weighs about 3 tons. So again, it looks like this. This is Gaia, launched in 11 years ago in 2013. It's also a space telescope with the ESA. It's ongoing right now, and it's going to get an accurate map of our galaxy, the Milky Way, which contains 100 billion stars, and it's looked at almost 2 billion objects about the velocity, brightness, temperature, and it has 2 optical telescopes and in the Lagrange point that is about 900,000 miles away. Okay, so it's got this sunshade on it, and it heats up hotter than negative 370 degrees, it's not going to work. So that's why sunshades are very important when we're talking about space telescopes like this. This is what it looks like, and this is the map of our galaxy in terms of density that it has composed of, which is helping explore our galaxy. This is Integral that launched 21 years ago, and that's a bit old, but it's still active right now, done by the ESA. It's measuring gamma rays and X-rays. X-rays are highly charged particles that come out of black stars that we'll get to in a little bit. But it weighs 4 tons, it's about 20 feet tall, and been around for 21 years. It looks like this compared to people. The Integral mission by ESA. And the ESA had the Mars Express that launched back about 21 years ago. And it's still functioning, but they lost the lander to go on Mars, but the orbiter is still going around Mars. And what's special about that? Well, in combination with the Mars Reconnaissance Orbiter, they're able to find some fascinating things out about Mars. First of all, these are in the northern North Pole area, where there's dunes here that are hundreds of feet tall and have snow which is frozen carbon dioxide or dry ice on them. It has like a crater full of dry ice. Mars once had channelized streams on it, that is flowing water on it. But 4 billion years ago, something happened. The inside of Mars solidified, and therefore a dynamo was not made, and therefore it lost its magnetic shield that would protect it from solar rays, well, specifically highly charged particles from the sun hitting it, and which destroyed its atmosphere, making Mars a dead, dry, arid, frozen planet. So it once had these streams on it like this, and also this orbiter also found information on Phobos, its moon of Mars. You see these marks right here? These are stretch marks. This moon is breaking apart because it's inching toward Mars, and one day will break up 50 million years from now, and Mars will have a halo around it at that time. Now this is a fun one. This is JUICE. This is the Jupiter Icy Moons Explorer. This left Earth in 23, and we'll get there in 31 to go to get to the moons of Jupiter. Jupiter's 500 million miles from this, and has to go. This satellite had to go around numerous places like the Moon and Earth to be able to pick up speed to go out there. So it's going to explore the moons of icy moons like Callisto, Ganymede, and Europa. Let's take a look at JUICE. It's got a 10-foot antenna or dish to be able to receive information. Be up there in 2031, and will look like this. It'll have optical cameras, a spectrograph, that means to be able to look at the spectrums of various elements, radar sounder, radiation monitor, an altimeter, how high things are up, magnetometer, measure magnetic resonance, and these other situations. But it has 900 square feet of solar panels on it, because the sun is one half the power the sun does out there. So it's got all this equipment on it, and what it does is going to explore these icy moons. And these icy moons have thick layers of ice on them that are over 10 miles thick, 10 miles to maybe 30 or 40 miles thick. And underneath each of these moons, underneath that ice, is an ocean with twice the amount of water that we have here on Earth. It's up to 400 feet thick. Oh, I'm sorry, 40 miles thick of water. And what it does is, as these moons revolve on their axis and then spin around Jupiter, Jupiter is able to have a lot of power over it because they have a lot of gravitational force. You can put 1,300 Earths inside Jupiter. So what it does is it pushes and pulls on the mantle of these moons. And that makes the mantle inside these moons more plastic, viscous, and pliable. In other words, it makes it more almost kind of liquidy, almost. And it's able to, in the mantle here, then release nutrients and chemicals into the saltwater ocean that these moons have. And this is called, on our Earth, this happens, it's called hydrothermal vents. So it's able to release this. And on Earth, without sunlight, these hydrothermal vents attract microscopic sulfur-based and carbon-based microscopic bacteria, which might be present in these oceans. And this pushing and pulling of the mantle is called tidal heating. That's what we think might be going on under there. That is why they want to go to these specific moons, because of this tidal heating. Let's take a look at each of these moons in a little more detail. Like Ganymede, which is 3,200 miles in diameter. It'll have this thick layer of icy crust on it, and below that it'll have the saltwater ocean, and have some ice, and then a rocky mantle, and then inside it has a solid iron core with liquid iron around it, which means it's able to produce a magnetic field because of the dynamo that's produced inside this moon. And with that, you get a magnetic field around Ganymede, and it has aurora borealis around it also. because of this. This is absolutely fascinating, and when an asteroid gets too close to Jupiter, it'll start to break up because Jupiter wants to pull on it so much. So when it does that and crashes into Ganymede, it'll make these craters in a row like this. And this is what it breaks up doing this. It's an icy surface like this with these kind of markings on it. And Callisto is the third larger than first moon. It's hot marked with hundreds of thousands of craters on it that look like this. And again, it'll have ice, a saltwater ocean, more ice, and rock and metal core on the inside. It does not have a magnetic field. And the prize of the whole thing is Europa, which is 2,000 miles in diameter. And you'll see Europa has these lines on them all over the place, like spiderweb lines. These are really ice canyons that are 15 miles wide and up to a couple miles deep. And underneath the ice, of course, is the saltwater ocean. So the saltwater ocean then oozes up and is able to make these red splotches, which is from the ice, from the salt water in the ocean below it, on top of the surface here. And Europa doesn't have any craters that we can see because the area is constantly being replenished with fresh ice. There's geysers on it that's able to do that. These are what the ice canyons would look like. They'd be as wide as the villages is wide and look like this. So that's what's going on in Europa. It's about 250 degrees below zero there and does not have any atmosphere. And again, you can see the stretch marks and the lines on this. This is what it exactly looks like. This weighs 13,000 pounds, and it has batteries in it when it gets behind any moon. What's it going to do? It's going to go around Jupiter a number of times and then visit these moons as flybys as it goes around. And the batteries in the back go help out when it goes behind the moon. Maybe I said that. And it's got these geysers coming up that go over 100 feet in the air to be able to replenish the surface with ice, new fresh ice. That's what's going on there. In 2026, ESA is going to launch Plato, the Planetary Transit and Oscillation of Stars. What this is a space telescope. It has 26 cameras on it, and it's going to be it's going to look at exoplanets in our galaxy, the Milky Way. So far we've identified 7,000 exoplanets. That means there's a host sun and there's a planet going around it. And we're able to get information on this, which is what this is going to do. It's going to be in the L2 orbit. And how this works is that when the exoplanet is in front of its host sun, it'll dim the brightness of that sun. And the dim becomes a dip in what we see. And the dip is what we can measure. If it's a short dip, that means the planet is too close to its host sun, which means it won't harbor water. That is like a Mercury. It'll be like 800, 900 degrees. And if the dip is longer, it might be an ice planet further out from the outside of it. What we're looking for are planets that are Earth-like, that is in the Goldilocks zone, so with water that's able to be in liquid form, like from water between about 32 degrees all the way up to 220 degrees. This is what we want. So we're measuring this, and with this dip, they're able to measure on the outside of it, that is the atmospheres of these exoplanets, and be able to get a spectrograph reading on it as what elements compose the atmospheric composition of these exoplanets. This is how they determine things. They don't see the planet, rather they infer it's there from the dip in the brightness of the sun, the host sun that it's at. And we're finding more and more of them out. Remember, there are 100 billion stars in the Milky Way, and most of them have solar systems. Some 8 planets like ours, some more, some just a couple. Like Alpha Centauri, it has two planets around it, but they're very hot, they're too close to it. And so the next generation planet finder is called Plato, and is about this tall with these cameras on it. Next, oh, not next, it's studying 200,000 stars in our galaxy, and you'll notice that it's looking for these planets in solar systems that could look like this. And remember that not only that these host stars have solar systems, their host planets might have moons. We have 293 moons in our solar system. So if you find another solar system, it might have that many. So it's unlimited the amount of number that there are of moons and planets in our galaxy alone. In 2028, we'll make the ExoMars rover or the Rosalind Franklin rover. They had a problem with this because it was supposed to go up in 22. But the lander was to be made by Russia, and the EU has nothing to do with Russia anymore. So they kicked Russia out, and they want to find a better partner to put this up in 26 to be able to build this and to land on it and then have this rover on it. So what it's going to be is going to look like this. This rover will go up in 20 and be up there in 28. We'll have 6 wheels. It'll be solar powered. It will weigh 660 pounds and be about a third of the size as Perseverance or Curiosity. And we'll have a 7-month mission on Mars to look at what they have up there, named after her. It'll have a mast on it with a camera, and it has a 2-meter drill on it. I guess they folded up to put it in here. So this is how this works. So on Mars, what it's going to find is some fascinating facts about it. First of all, Mars is one of these desolate, dry, barren places, as mentioned. So they have a lot of wind on it, and they make these dust devils on it that leave these kind of trails on it, like swirling loops that you can see from space. And they have the solar system's largest volcano, which is Mons Olympia, which is the size of the state of Arizona and 15 miles tall. It's so tall, it's 3 times taller than Mount Everest and peers into the Martian atmosphere. As well as they have Valles Marineris, a canyon the size of the United States, and it's 2,500 miles long, and it's 4 to 5 miles deep. I think it's part of a plate. It's part of a breaking off plate here on plate tectonics on Mars. So those are some of the things on Mars that it's seeing. Plus, it snows carbon dioxide, about 3 or 4 trillion tons of it a year. This is in the North Pole area where it snows, and the dark splotches are the ground not being snow on it. And here's like a valley of it. And if you can see this from space, that means that these cliffs are 2 or 3 miles tall. Imagine that. Imagine when it once had water and flowed, it would flow over these cliffs and go into here, back in the day when that happened. And it'll be solar powered, obviously. And what happens with these rovers is that the dust storms put too much dust on them, and that makes them not work. But the same dust storms come along and blow out the dust, so they're able to last 6 and 7 times longer for these rovers than usual. It'll come off like this. And this rover, the Rosalind Franklin rover, will be in the Oxyoplanum area, which is in the South Pole. It once had an ocean there the size of the Atlantic Ocean, fed by channelized streams. But obviously Mars lost that 6 billion years ago. So it wants to look for microbial fossils on rocks. The odds of them finding that are less than 1 in 100, but at least they're looking. This is the aerial space mission. This will launch in 2029. It'll be another space telescope looking for exoplanets. It'll have a 4-foot mirror, weigh about 3 to 4 tons, and it will observe about 1,000 exoplanets, from rocky planets to gas giants. In about 20 light years from us, this is the TRAPPIST system, which is one of the most famous ones. It has a host sun, and then planets about Earth size. But most of the time, the planets that we find in exoplanets are about 2 or 3 times the size of Earth. That means they're called super-Earths, is what we find. And they have short velocities, short time periods to go around their sun, which means they're close to their sun, which means they're hot. But most planets that we find are rocky ones, not gas giants, and most of them are like I said, about 2.5 times the size of Earth, from what we're finding. So it's able to peer through, again, the atmosphere of these exoplanets, or the dip that I talked about, and if they can find water, that's the holy grail, or H2O, or carbon dioxide, or methane, or nitrogen, or sulfur dioxide, but they really want to find the Goldilocks planet, not too hot, not too cold. And this is what it would look like going across the face, which makes a dip in the brightness of the host sun. And this is the village satellite here. This is a tracking satellite the village has put up. They're trying to find any kind of street that goes straight. Clearly they haven't found one because it's built on non-Euclidean geometry. So they're going to keep looking for that. And this is another one, the satellite called the Roundabout Runaround. And that is, there are special rocks found inside right in the center of roundabouts. And if you're in possession of these rocks, it makes you want to play pickleball or golf a lot, makes you look for discount coupons, eat at 4 o'clock and go to bed at 8 o'clock. So that's what these are about. Okay. This is what NASA has. This is the Juno spacecraft that's been around for 8 years. It's orbiting Jupiter, and that's one heck of a planet. This summer, the Hubble Space Telescope found gravity waves on Jupiter with a great red spot, which is a giant cyclonic storm that's been brewing for over 500 years. It's the size of 2 or 3 Earths right here on Jupiter. So, on Jupiter, there is no surface. And that is, if a probe goes into it, you descend into the clouds of ammonia and hydrogen, mainly hydrogen, and you go deeper and the pressure builds up. So much so that you go through a lot of Jupiter, and the pressure becomes 1 million times what we have here on Earth. And it becomes so hot inside Jupiter that hydrogen turns to liquid, so they have ocean of liquid inside the core of Jupiter. This generates a lot of heat. The heat then goes up into the upper atmosphere made of hydrogen and these clouds of ammonia and hydrogen and form storms. And the winds are intense. At the poles of Jupiter, it's 900 mph, and in the center, it's 400. So, this is what happens with Jupiter here, and there's actually lightning. It's 10 times stronger than ours in their atmosphere. It's dozens and dozens of miles thick, and you descend as you go into it, and it just gets hotter and more pressure as you go deep inside. This is what this looks like, and she's a beauty. We have the Hubble Space Telescope that is an 8-foot mirror, over 20 years old, and the JWST is up with 32 feet of mirror with 16 hexagonal shells, and beneath it, it has a layers of insulation the size of a tennis court to prevent it from being too hot. Too hot, and again, it doesn't work. This is the Chandra X-ray telescope. It's been up for 20 years, and what it does, it looks for X-rays. And that's real easy to say, it looks for X-rays. What's going on here? If we have a star that's 2.5 times bigger than our sun, it starts running out of its energy. It'll start blow out into a red giant. The outer shell will then blow away and become a nova. What's left will be a core. The core then will implode to become a singularity, a point of infinite density, and will then become a black hole that is attracting really debris from its other star, which is its twin star. Usually they are binary stars, and it will attract that and then have debris floating around here in particles and get super, super hot and turn into X-rays, which is how we're able to detect it even though we can't see it. So that's why this kind of machine is important to find out where black holes are. We infer that it's there based on the X-rays that it's emitted from this intense radiation that's coming off from it. We're also going to go out to Venus with the Da Vinci and Veritas probes. These are in the future with NASA. And Da Vinci probe will go explore the top of Venus' atmosphere where there is sulfuric acid, and explore a mountainous region known as Alpha Reggio. And then we'll send a probe into Venus. And this probe will descend on a parachute and take an hour to get down there. The probe, though, will be subjected to pressure. It's 90 times that of what Earth's, or 90 times 14.5. PSI, and will experience temperatures of about 860, 880 degrees Fahrenheit. So it won't survive, but they want to get a picture of it. We'll talk more about Venus, as it has the tallest mountain range, which is 7 miles tall, Maxwell Mountains. And this is a reflective material that's a bit cooler volcanic material than the other volcanic material on this planet at higher up altitudes. Now we're going to have the Veritas, Venus emissivity, radio science, INSAR, topography, and spectroscopy. Well, anyway, it's going to orbit Venus. Venus has 85,000 volcanoes on it, and with no plate tectonics. So that lava is coming up from the center of Venus. And there's so much pressure on it that sometimes it also makes pancake domes out of these things. I was first to talk about the runaway greenhouse effect on Venus. Too much carbon dioxide, which is what the atmosphere is, will lead to heat being trapped in by the sun, which will heat it up and the heat won't be able to escape. So that's why it's that temperature of near 900 degrees. And I also talked about a nuclear winter. If we ever had a nuclear war, the particles going around Earth from the debris of that will block the Earth's sunlight and prevent a lot of sunlight from coming in and crops being grown. So a lot of people dismiss this. They think that the Earth is warming up naturally. Well, I say no, and I've always said no to that, because we put in 40 gigatons of CO2, and we don't want to end up like Venus. So, going on. We also have the NASA's Lucy probe that's going out to the 7 primordial Trojan asteroids in the asteroid belt, and it's launched in 2021. It's a 12-year mission, and we'll go to all these particular asteroids, and I can't pronounce them. Euripides, it's easy for you to say, Eris, whatever. And it's going to all these ones. It's solar powered. It has 50 feet of solar panels on it to explore these ancient relics of what the solar system was back 4.5 billion years ago. And now the Europa Clipper. This is the fascinating one. It just launched a couple weeks ago. It'll get to Europa, that moon, icy moon of Jupiter, in 2030. And it'll have 100 feet of solar panels. It'll have a mass spectrometer on it, an ice-penetrating radar, magnetometers, thermal imaging, and these kind of cameras, and a reconnaissance camera. And it'll fly around Jupiter about 35 times and go near Europa about that many times. It'll look like this. It'll have 6,000 pounds of fuel to it and 24 engines on it. And those solar panels are able to produce 150 watts of power. And it will make 50 flybys of Jupiter and get close and take pictures of Europa with these 9 instruments that it has. So it's really designed to get close to Europa with those spiderweb-like veins that we saw on it. Because Europa has, again, the ice shell, the ocean, a rocky interior, and a metallic core. And on this moon, it'll have geysers coming up to 100 feet tall that produce all these new fresh ice on Europa. It'll have 50-foot pinnacles on it of ice, twice as tall as your house, and it'll have these ice canyons that look like this and fractured ice look like this. We are very excited about this, and also about the way it works. First of all, it'll be 20 minutes before we can get that satellite information to it, so it's able to work on its own, able to think on its own. And what's inside of it is fascinating, as well as what it's exploring. Because inside of it, it has 2 gyroscopes on it that are 2 feet in diameter to keep it stabilized. It also has these transistors in it. But these transistors need to be protected because of the intense radiation that Jupiter gives out 20,000 times more than Earth. So they have to be protected with a 300-pound vault around them made of aluminum zinc alloy. And they're worried about these transistors, so they're going to put a canary box outside of this with regular transistors in them. And if these ones get damaged, they know when to pull back from this. this compared to the size of a human, like right here. So this is why they're worried about that it could be destroyed by Jupiter's radiation. That's what they're doing to protect what they have. And again, it's a saltwater ocean with this going on. We're very excited about this and produce a lot of good information. This is Psyche. This is a visit to an asteroid, a metallic one, that's out between Mars and Jupiter, and it will launch in 2023. And we'll get to Psyche, this asteroid, in 2029. We'll spend a year and 3/4 there to 2031. It'll orbit this asteroid that's 173 miles in diameter at its widest point. And it's made of metal. It is 16 feet tall. It weighs about 4 tons. And like this, it's got an area for solar panels about the size, again, about the size of a tennis court. And it's going to orbit this metallic asteroid. So this is what it looks like. And it's made out of, this asteroid is made out of iron and nickel. And they think it could be the iron-rich core of a planetesimal that is a building block of a rocky planet. We think this is how planets may have started out, like a starter planet with the inside of it like this, with the core of it, and then things building around that. It'll have 2,300 pounds of xenon in it, which is ion propulsion, and we'll get there in 2029. And it's worth this kind of money if we could ever harness it. But I think it has a lot more silicate on it than anything else. So they're trying to find out about how the solar system developed, which is why they're sending them to the asteroid area between Mars and Jupiter. This is the Parker Solar Probe that's currently visiting the sun, and will make its last trip to the sun in 6 weeks on Christmas Eve night of this year. And it weighs 1,350 pounds and is 10 feet in length. And it has this thermal shield on it when it gets close to the sun that's 4.5 inches thick of carbon composite. It folds up its solar panels when it gets close. So what it's doing is, and this sounds a bit confusing, is it's this big, and it's making concentric circles to get near the sun. It's getting closer to the sun every time. It's gone around about 12 times. And the last one will bring it very close to the sun, to be able almost to touch it. So the sun is able to have this gravitational well, so every time the probe gets closer, it goes a little bit faster, goes out to the orbit of Venus, and then comes back to it to study it. It'll look like this. And it'll be able to survive up to 2,500 degrees. And when it gets closest to it in 6 weeks, it'll be within less than 4 million miles of the sun. We've never been that close to the sun before. This is as close as we can get to it, and we'll go at 430,000 miles per hour, which is pretty incredible. Again, with this shield and these flybys, it making it closer and closer. This is a dynamic way to look at the sun. Now, this one's a fun one to talk about. This is the Dragonfly mission. This will be done by NASA, and it's a mission to the moon of Saturn called Titan. And on Titan, it's the only moon that has an atmosphere. So, it'll launch in 27 and land there in 2034. And Titan has an atmosphere composed of 98% nitrogen. It is 800 million miles away from Earth. And when we went up there once, we had a probe up there about 20 years ago, and it just took a lot of pictures and landed and didn't take any more. But it found these channelized streams here, not by water, but by methane. So we're going to take a look at this right now. It's not only the largest moon of Saturn, but it has a thick atmosphere and the gravity is very low. So what they want to do is land this helicopter thing on Titan. It'll unfold itself and will take off like a helicopter because it has 8 rotors on it, each with about 1 meter long for one of these blades. Have 8 of them and be nuclear powered. It'll be able to take off and land like a helicopter, travel at up to 4,000 feet up at 30 meters, at 10 meters per second, and go for about 30 minutes. So this will greatly increase our understanding of a very unique moon doing this. It'll weigh about 1,000 pounds and be about the size of the Curiosity or Perseverance on Mars. And it'll be in a place that has hydrocarbons on it like methane, nitrogen, hydrogen, and ammonia, and have cryovolcanoes on it. That is volcanoes that spew out these kind of hydrocarbons on the surface. And this moon is very unique. It has seas of liquid methane, which becomes liquid. Methane's a gas on our planet, we all know, but it becomes liquefied at -161. And it has seas on it. Some of these seas are tens of thousands of square miles big and go up hundreds of feet deep of these liquid methane seas. So it actually rains methane on Titan. The methane evaporates, goes into clouds, and makes clouds like we have here, condenses and forms methane rain. And there's actually lightning, and yes, there's thunder because there's nitrogen in the atmosphere. And it's really like a desert planet, and these storms ravage Titan by taking 13 years from going from pole to pole, and then pole to pole back, taking about 30 years to do this. And this is an actual picture of it from the Huygens Cassini probe that we took. You can see there are canyons here made by methane that made it into channels here. So this is what this is doing. And this is what it looks like on the surface of Titan with these channelized streams. One of these lakes in the poles is as big as Lake Superior. Another one is as big as the Caspian Sea. Caspian Sea is the largest freshwater lake in the world. So that's how much liquid methane there is on this planet. And it has storms like this on it, making these channelized streams. So it might look something like this, with these canyons that have been carved out by this liquid methane and seas of it like this. And much like the American Southwest, we see these kind of formations, these canyons that are carved out after tens of millions of years of water running through it on and off. Most of the time it's dry, but then when these big floods come through it, they carve these channels, they carve these canyons out, and this is what we might see in a different way on Titan. Now, a couple things to say about it. This probe cost $3.3 billion, and it's just, and like I said, it's 800 million miles away, so it'll take quite a long time to get there. And I usually don't say this in a science talk, but if you're feeling down and depressed about something, and you want to look forward to something in life, well, this is something to look forward to, because it will have videos and pictures of this, like a world we've never ever seen where it rains methane on it. So keep that in mind. This is the Nancy Grace Roman telescope. It'll launch in 2027. It'll be a Hubble-class telescope named after her, the mother of the Hubble, and will be solar panels. And the wonderful thing about this, it has a mirror on it. It's an 8-foot mirror. It weighs 410 pounds. That's 1/4 of the weight that the Hubble telescope mirror has on it. This is what we've been able to do with mirrors now, make them lighter. And it'll see in the ultraviolet and infrared, which is really good rather than just white light. It'll help us with our understanding. It'll be in the L2, the understanding of the universe. It'll be in the L2 orbit. As of August 23, there have been 18 spacecraft missions operating in Mars's orbit, 7 which are currently active, like the Mars Reconnaissance Orbit. We have the Curiosity and Perseverance on Mars. They're to return a sample with Perseverance, to have a mission to go out there, pick up a sample and take it back, but that's been cut because they cut 520 jobs from NASA. So that's been cut. And they have extremely large telescopes. These are being built in the Atacama Desert in Chile. These are very large space telescopes, now under construction. And the Atacama Desert here, it doesn't ever rain there for years. And it'll have 798 hexagonal mirrors on this, about 128 feet total of mirror space. And these mirrors have 4,100 sensors on them that operate thousands of times a second to be able to deal with the oscillation the mirrors would have because of the distortion that the Earth's atmosphere has. When we see through it and see through space, it becomes a bit distorted. So this will help out with this distortion. It's under construction, and I wanted to show you in the Atacama Desert, there are other telescopes being built, like the giant Magellan telescope that will have 7 large mirrors on it with about 70-foot diameter telescope that will look like this. There's no light pollution there, and no one lives there, and it doesn't rain, so it'd be wonderful to have these telescopes there in this particular area. This will help out with our understanding of the universe. We just heard Mark talk about SpaceX Starship, which they're being testing today. And other times, they do want to land on the moon like this. In order to do that, though, you need more information. So we had the Viper mission to go to the moon, but that was cut last year. This would be an automated robot with a light on it with solar power that would go into those craters where we talked about where the water is, so that we can understand what's going on there, rather than infer that it's being there. But, so that's been canceled. Again, in the Atkin Basin. Here. And we have Artemis 2 going up next year, which will be a manned mission from NASA. It will spend 8 days in space and go around the moon with a crew of 4 to come back. And I want you to know, on the spacecraft, which is the Orion spacecraft, which those astronauts will be in, it has these panels on it. These are solar panels that will help it make electricity to make air in the spacecraft. That's how they get it. Okay? And on Artemis 2, it'll have 4 RS-25 engines and almost 9 million pounds of thrust with boosters on it to be able to propel them up there to do this. It'll look like this. And this is what it looks like in the Orion, be able to fit 4 astronauts, and it does have a private toilet on it, about the size of an airplane toilet. So that's how they're able to have this for 8 days there. And then Artemis 3, they want to go up in 2026, but I think it would be delayed. But it's going to have 4 astronauts take a 30-day trip, and when it gets to the moon, 2 astronauts will circle above the moon like they did for Apollo, and 2 will take a ship called the Human Landing System on Mars, on the moon. And 2 astronauts then will stay down there for a week, having 5 missions, and probably to look for a place for a moon base and to do testing down there, while the other 2 astronauts circle around the moon. And then later on, these 2 astronauts will come back up this and meet the spaceship, upright to it, and they will come back to Earth, taking about 30 days. This is the crew for it, and they're preparing right now. This really needs to be built and tested. SpaceX and some other industries are trying to build this human landing system to go on the moon so they can be able to do this. And we might take the Starship to be able to do this, and the Starship can be refueled in space with a refueling tank, and they can do that. To go to the moon, to be able to have enough fuel to do this. We want to put a moon base on the moon with Artemis 3 in the 2030s, or a lunar base. Again, all areas would have to be covered with regolith, and it would have to have these solar panels on it, dozens and dozens of them, to be able to make the electricity, to be able to have the air, and to do things that we need. But this is all right now a pipe dream. I'm not clear when this will be built. It's not very clear. We don't have anything like this at all right now. Again, something like this, but these are just concepts doing this. In 2031, the ISS will be decommissioned and crash into the ocean. Instead, they're going to have a space station going around the moon called the Gateway. And Gateway will replace the ISS. Gateway will be built in space by these particular agencies. It will consist of 5 modules and be about 20 meters long, about 70, 80 feet long, and weigh about 63 tons and be 1/5 the size of the ISS. And we'll have a habitation module, a science one, a food storage one, entry and re-entry, and with solar panels. It'll be able to produce about 60 watts of power and be built in sections taken up by about 4 to 6 different missions, putting up by the Starship, Falcon Heavy to put up there. So it'll be built in segments, and it'll be going around the moon in a non-rectilinear halo orbit, which means it'll be 1,900 miles when it's closest to the moon and about 19,000 when it's away from it. And again, be built in modules. And what's special about this space station is that the Orion can attach to it and look like this, and then astronauts can live there. Actually, up to 4 astronauts can live there for a couple months. It's self-automated to be in this with giant solar panels helping out, and the human landing system also can attach onto it. So this is how they want to ferry astronauts to and from the moon with this kind of space station, using this kind of idea with maybe a moon base, and that's how they want to get around this. And maybe out to Mars also, a good way station or in-between station. And it'll look like this with the Artemis, the Orion attached to it. We want to have something like this in the future, but this is way off, maybe in our children's lifetime, maybe. And of course, we want to have the first humans on Mars. So all what we're dreaming of, huh? And lastly, this presentation is dedicated to the Harvard computers. These were women that worked in the 20s and 30s for the Harvard College Observatory. They weren't paid very much, maybe 50 cents, 25 cents an hour, but their job was to look at these photographic plates that had hundreds and hundreds of stars on them, and they had thousands of these plates. Their job was to classify these stars and number crunch them. And indeed, they did classify them, because the classification system we use today are because of these women. And we have a G2 sequence, main sequence star that's a yellow dwarf, and we still use that kind of sequences. We still use that kind of information. This information was very good because they classified stars so much they found different kinds of stars like Cepheid variables, stars that brighten and dim within months or weeks, and we can use them as cosmic yardsticks to find out how far away in our galaxy stars are from each other. They also find different kinds of galaxies, barbed ones, spiral ones, elliptical ones, and globular clusters. This all helped out Edwin Hubble to make Hubble's law, which means the further a galaxy is away from us, or redshifted, the faster it's receding from us, or it supports inflation, or how the universe is expanding currently. So the future is in your hands, and the future is ours to create, and thank you very much. That is the end.